So for this slide, actually we have discussed about the decimation in frequency by referring to the example previously. Okay. I have explained all the step and also the difference between the DIF and DIT, and also the twiddle factors. So the twiddle factors refer to the weight WT. Okay. So this is how we can we make the pairing of the butterfly or the X shape. When we have the number of sample equals to 8, as I mentioned before, you need to have 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. And then for the DIF, we label in increment value of binary, which is for the n equals to 8, we have 0, 0, 0, 0, 0, 1 until 1, 1, 1. And then for the DFT, it is the reverse value of binary number at the discrete signal. Okay. And how we can make the pairing nodes. So for example, here I use n equals to 3. Okay. For the DIF, the stage 1 will have the highest k, which is equals to number of sample 8. Okay, so x3 will be paired with x3 plus 8 divided by 2, where we will have x7. So x3 here will be paired with the x7 points. Okay, you can try by yourself by calculating when n equals to 0, n equals to 1, and n equals to 2. Okay, next is this one for the second stage. Okay, for the second stage, we have k equals to 2 to the power of 2, which is equal to 4. Okay, so we will have, for example, n equals to 1. So 1 plus 4 divided by 2, we will get 3. So this one, x1, will be coupled with will be paired with x3 points. So you can try by yourself for the 0.0, 0.4, and 0.5. Okay. And lastly, for the third stage, okay, for n equals to 8, we will have 3 stages: stage 1, stage 2, and stage 3. Okay, and this is the example how we can calculate the pairing at the stage 3, where our k is equals to 2. So this is example 4.3. You are given a discrete signal yn 4201. So you need to calculate using the fast Fourier transform. Since in this question it does not mention the what method to be used, whether it is DIT or DIF, so you can use any method. You can choose to use DIT or DIF. So this is the elevation of DIT, decimation in time. So this one also I have summarized at the previous slide. Okay, so this is the butterfly of DIT. Okay, and also the twiddle. Okay, so for the DIT, the value of k will have the lowest, where we have k equals to 2 at the first stage, and then the k is equal to 2 to the power of 2 at the second stage, and lastly at the third stage we have 2 to the power of 3, which is equal to number of sample 4 and 5. Okay, and lastly at stage 3, you can also try by yourself. Okay, and to see whether you understand or not, you can try example 4.4. Okay, and this is the answer for the example 4.4. You need to solve using step by step that I have shown to you. So first you need to draw the lines. Okay, the lines refer to the number of sample, and then the second step is to label the discrete signal and the DFT. Okay, and also the binary number here for the IT, we have ascending at the discrete signal. Okay, and then the third stage is to find the pair. Okay, to find the pair of butterfly, and then the fourth stage is to calculate the weight value, and lastly to get the value for each point here. Okay, and of course you will get the DFT signal after you calculate E1, F1, G1 and H1. Okay, so this is another example. Okay, for this example, actually it is a bit different compared to the one that I have shown to you. What is the difference here is given the signal of the DFT signal. Previously, we are given the discrete signal. In this question, we are given the DFT signal. Okay, so for this question, we need to arrange the DFT at the right side. Okay, so for example here 0 0 is 6, next followed by 3 minus j, and then negative 8 and 3 plus g. Why we can arrange it in ascending order? Because this technique use the DIT method. Okay, so for the DIT method, the binary number is arranged in ascending order at the DFT side. Okay, alright, so you can solve by referring to this solution. Okay, this is, and lastly you will get the xn. Okay, this is like you do the inverse Fourier transform to get the discrete signal. Okay, this is exercise 4.4. So in 4.4, you need to calculate the value of A, B, C, and D. Next, this is also exercise for you to be done. Okay, this is the answer. Alright, so that's all for the fast Fourier transform lecture. Hope you can try by yourself at home and give feedback which part that you want me to elaborate more. Okay, thank you for listening to the video.